Welcome to RECONSTRUCT Center for Theoretical Physics. This is another lecture on this lecture series, Electricity and Magnetism. And in this lecture, I am going to establish connection between potential and vector field, electric field E. What is the relation between potential and vector E? So, in the last lecture, we have seen that d phi minus d phi change in the potential energy equal to E dot dl. dl is the displacement. Now suppose that this dl, or you can call it a line element dl, is in the x direction. This is dl. So instead of dl we can write dl equal to I dx, and component of vector E along this x coordinate is ex. So we can write minus d phi equal to E dot dl equal to ex dot I dx minus d phi, or ex equal to minus d phi by dx, exi equal to minus di phi by dx, or we can say that ex equal to minus d phi by dx. This is the component of vector field E along the x coordinate system. Same way, Ey is equal to minus d phi by dy, and Ez is equal to minus d phi by dz. It means we can write E equal to minus d phi by dx, I minus d phi by dyj minus d phi by dz k, or we can also write minus dy dx I plus dy by dz j y plus d by dz k phi. We can write this way, or also we know that phi also can have what you call a component. So we can also write E equal to gradient of phi. So this is the connection with minus gradient of phi. So E equal to electric field E equal to minus gradient of potential energy. So this is the connection between gradient of phi. So the relation between potential and vector field E is E equal to minus gradient of potential. Now how we can use this relation to solve a problem? Suppose potential energy, which is the function of x and y, is equal to minus axy. So how we can solve this one? E equal to minus dAxy by dxi minus d minus dxy minus axy by dyj, and which is ay plus axj. This is the electric field, component of the electric field. Ay I Ax J. So this is how we can solve any problem which is any problem where potential is given, and we can use this relation to find the electric field. Now there is a term called equipotential surface. Equipotential surface are those surface where at each point potential is same. So this is the equipotential surface, and electric field is tangent to this equipotential surface. This is the potential, and this dot line is the electric field. So this is the equipotential surface, that the surface at which at each point the potential phi has the same value. It means if there is a phi here, the value of phi will be same at here. So at each point potential phi will be the same, and vector E at each point is directed along the normal to the equipotential surface. So this electric field is tangent to the this potential phi. So this is the visualization of potential phi and vector field E.